and welcome. I'm April Quinn-Paquette, Global Marketing Manager for Software here at SciEx, and today I have with me Himanshu Malani, Application Support Scientist at SciEx. In this technical note, we're highlighting the characterization of GLP-1 impurities using EAD. Himanshu, I'd like you to tell us more.
Yeah, hi April. Thanks for this, lovely introduction. So basically, one of the biggest challenges with peptide characterization is detecting low level of impurities, and that too with confidence. That is where the xenotroph systems come into picture. The xenotrap technology allows us to capture ions that are otherwise lost and then releases them efficiently into the TOF analyzer. In this study itself, we delivered up to 20-fold improvement in the MSMS signal sensitivity, allowing us to characterize low-level impurities as low as 0.02% with confidence. This is the kind of confidence we hope that this technology can deliver to the scientists so that everyday peptide characterization becomes an easy task.
Wow, 20-fold increase. That's amazing. So what advantages does the EAD provide compared with traditional CID fragmentation?
So, CID will always remain a valuable tool for peptide analysis, but when it comes to labile modifications or complex structures, it struggles a bit. So that is where EAD comes into the picture. The SciEx EAD uses electron-based fragmentation mechanism that generates complementary fragment ions while preserving the sensitive and labile modifications. This results in improved sequence coverage, better localization of modification, and higher confidence in characterization of degradations. This is where EAD is superior to the conventional CID mechanism.
That's excellent. That's great news. So the isomer identification remains a major challenge in peptide analysis. So how does EAD help?
Yeah. So as I said, CID is often unable to characterize labile modifications. And when it comes to isomeric impurities, the problem is a much complex one. EAD generates unique diagnostic fragments, allowing us to confidently characterize isomers such as aspartate versus isoaspartate or leucine versus isoleucine. For example, in this case, we have shown that the characteristic fragment of C plus 57 Dalton and Z minus 57 Dalton provide a clear evidence of isoaspartate formation, differentiating it from aspartate ions. These capabilities provide the unique edge to EAD technology, allowing accurate structural characterization and improved confidence in product quality assessments.
And confidence in the results is super important. So beyond the hardware, how does Molecule Profiler software support this GLP-1 workflow?
Now that we are dealing with a complex technology, we also need a very powerful software to process that equally complex data. That is where Molecule Profiler comes into picture. Molecule Profiler automates the impurity discovery and structural characterization of these impurities, the complete parent sequence, by matching the observed fragments with the theoretical ones. It enables rapid identification of these impurities and identifies truncations, oxidation, and other degradation variants with ease. This significantly reduces the time required for manual data review, allowing the scientists to get more actionable answers rather than spend time on manual data review.
That's great. And also, what role did Biologics Explorer software play in delivering confident results in this study?
So here I'd like to say that Biologics Explorer software added another layer of confidence when dealing with this complex data. So since EAD generated unique fragments, we need a software that can automatically pick up these characteristic unique fragments and tell us that this is aspartate versus this is isoaspartate. In this study, the Biologics Explorer software automatically picked up these unique diagnostic ions and simplified the spectral analysis by highlighting the critical evidence. This improves the turnaround time from raw data to actual answers.
So if you had to summarize the key message from this work, what would it be?
The key message from this work is, Xenotroph system, the Molecule Profiler software, and Biologics Explorer software together make a very comprehensive solution for peptide characterization. It's a very powerful combination that is able to characterize the ultra low level impurities, confident identification of isomers, as well as streamlined data analysis. The result, according to me, is more reliable peptide characterization. And if we talk about the real world, It is a faster turnaround time from the bench to the bed.
So it's not just about detecting impurities, it's about turning those complex analytical data into actionable answers faster than usual.
Absolutely.
Great insight, Himanshu. Thank you so much for joining me today.
Yeah. Thank you for having me, April.
Thank you.